Okay, I just want to set you up with a little bit of a thought experiment or a scrap paper experiment based on what we were talking about, temperature and aspect and slope asymmetry. So I'll set you off and talk about it very briefly, and then you take it away and try applying this to different environments or different settings of your own particular preference. So we have a valley with an aspect, different slopes facing different directions, and I've set up the equator down there, so the sun is coming in from this angle. So this is the sunnier slope and this is the shadier slope. So what's the impact of that going to be ultimately on geomorphology and landform evolution? But initially, starting from our lecture this week on temperature, what's the effect going to be on temperature? Well, the sunnier slope is going to be the warmer slope. It's going to warm up earlier in the spring, it's going to reach higher temperatures, it's going to warm up more at the start of the day. So imagine, for example, we've had snowfall on this. Snowfall will last longer into the spring on the shady side of the slope, and it will melt away earlier in the spring on the sunny side of the slope. What's that going to do to spring moisture content? We're going to have a water supply into the slope for longer into the year on that side, for less long into the year on that side. Now when you do this for yourself, you could do versions for high latitude examples in polar areas with permafrost and lots of snow, and in low latitude environments where we're talking about hotter conditions. Well, this side is going to get hotter. You'd expect it therefore to be drier. There's going to be more evaporation, more evapotranspiration. What's that going to do to vegetation? You're going to probably have maybe fewer plants, less vegetation on this side because it's drier, and more on that side because you've got more moisture, more humidity. What's going to happen to soil development then with more plants and higher humidity? You'd expect maybe more weathering and more organic material. So we've got deeper soils and thicker vegetation, thinner vegetation, less soil development. So what happens when it rains? Precipitation, lots of interception on this side, lots of plants and vegetation to slow down any overland flow. On this side, less interception, more overland flow because there's less soil to be for the water to infiltrate into, more soil for the water to infiltrate into. So overland flow, erosion, transport, sedimentation. Where's that eroded material going to go? It's going to end up down here in the river at the bottom of the valley, if there is a river at the bottom of the valley. So, changing colour, up here we'd be expecting erosion as that overland flow is picking up sediment and carrying it downstream. We'd expect less of that over here because of the vegetation protection and because we've got soil for infiltration of water into the soil. We'd also expect then deposition down here in the valley bottom, certainly if there's enough erosion here to overwhelm the capacity of the river to carry it away. If we're getting deposition at the bottom of this, then we're going to push that stream over to the your left-hand side of this valley bottom. So we're likely then to be getting undercutting here, possible mass movements into there, and we're steepening that side of the valley. So over here we're making the valley more gentle, and over here we're steepening it. So gradually we're going from a symmetrical valley towards a less symmetrical valley. Now, that's just a rough idea with just a few conditions thrown in. What I'd like you to do is to think about your own specific environment where particular things are happening. Look, pick some place off Google Earth or choose somewhere that you know, or do it in your local area. And think through, thinking back to what we said in the temperature lecture, think through what's going on here and make a better version of this diagram for yourselves.